Hello ladies and gentlemen, welcome to our last video. We're taking a look at just a couple of pages here at the end of Unit R. We're looking at something called the R-squared value and then how to use Excel to calculate correlations and regression. So let's talk about this thing called the R-squared value. The R-squared value is called the coefficient of determination. It's a measure of how well the independent variable x explains the dependent variable y. And it's expressed as either a decimal or as a percentage. It's in the range of 0 to 1. And so if you have an R-squared close to 0, it means that it's a poor fit. It's not a good fit at all. So that means that the x's don't do much in terms of explaining the y values. If it's close to 1, then it means a very strong relationship, a very good fit. So you can see that there's actually a relationship here between the R-squared value and the little r that we calculated before. When we get into 307, what we'll notice here is that it's actually an aggregate measure. And what I mean by that is that let's go back to the original variables that we had here. So here's our dependent variable y, and we're asking the question, well, what is it that determines the grade of a person here? And so we're looking at x. And remember once again that it's hard to talk about causality here. Is x actually a determinant of y or not? So we're actually asking, is it strongly related to it? It likely is a determinant, but again, it's hard to control for all possible factors and variables when you're dealing with socioeconomic experiments, because we're not dealing with things in a petri dish, right? So you can't control everything. But the wider question here then is, this is what we call a simple linear regression model. That is, that we've got one x variable explaining one y variable. Now, that doesn't mean the number of observations. The number of observations, of course, is 15. That's our n. I'm talking about the number of variables, the number of measures. So in a simple linear regression, you've got one x variable and one y variable. So we're only looking at using the number of hours that a student studies to explain the grade that they get. When we get into multiple regression in Business 307, we'll be talking about, well, what are some of the other x variables that we could add here? So for instance, we could measure the person's age and have that as another x variable. So we'd have x1 and x2. So now we've got the hours, and then we've got the age, and then we could look at maybe the number of hours of sleep that they get per night, and so that would be another one, or the number of hours that they work in an outside job per week, and so that would be something else. We could also look at the gender. Now, the problem with gender is that that's actually a nominal variable. And with regression, you're dealing with interval variables and how they relate to each other. We will talk in Business 307 about how you handle things like gender, but that's many, many months down the road here. So the important thing to note here then is that when you take a look at the relationship between x and y, it comes up with a single little r value. That's the correlation between the two. If you were to square that value, little r squared, you'd get big R squared. But that only works with a simple linear regression model where you have one x variable. When you've got a number of x variables, so again, hours and age and number of hours of sleep and so on like that, then there's actually a separate r value for each y variable, the grade, and that x variable. So there'd be a separate r. And in fact, there's also separate r's for each pairing of x variables. So between the hours and between the age of the person. So you got a whole bunch of r's, little r's here. But there's one r squared variable. And what it's looking at is if you were to take all of the x variables together, so the hours and the age and the hours of sleep and the hours working in an outside job, and if you were to put them all together as an aggregate measure here, and then find out how much does that big bundle of values then, all that data, explain the grades of a student, then that's the R-squared value. So it's an aggregate measure. So we're going to come back here then and say that it is an aggregate measure, which will make a lot more sense when we're talking about multiple regression. But in a simple linear regression model, which is all we're looking at in this unit, is little r squared is equal to r squared. So it's kind of trivial, but it won't be when we get into our 307 course. Okay, now you can also see why r squared goes from 0 to +1. Little r, of course, went from -1 up to +1, but when you square a negative number, then you get a positive number. So r squared goes from 0 up to +1. So in our particular case, then, it's really easy to calculate the r squared value. R squared would just simply be equal to the little r value that we calculated squared. So that will be equal to positive 0.570 squared, and that turns out to be 0.325. Now the r squared value is usually expressed as a percentage, so it would be 32.5%. And the interpretation of that then is that we're saying here that 32.5% of the variation in grades is caused by hours studied. Later in 307, we will look at what determines the price of a house. And we'll take a look at things like the size of the house, the age of the house, the number of rooms, the number of bathrooms, and so on like this, number of garage stalls. And we'll come up with an r squared value. It'll turn out to be about 67% in the first example that we'll look at. And we'll say that all of these half dozen or so variables together explain 67% of the variation in the price of a house. So it's an aggregate measure. Let's go down here and just take a look here at Excel. I don't want you to know this for 306. It's something that I wanted to put in here to show you how you actually calculate correlations. So there's actually a really neat little function here called Correl. And so it will give you your little r. But more importantly here, if you follow these steps down here, you'll come up with the regression output. What I do want you to know is how to read the output. So you could certainly be given some output, say on an exam, and you need to be able to read the regression output. So these are just steps in terms of how to actually fill in the dialog boxes and so on. But I want to come down to this point here where we take a look at the actual output here. Now, I've actually taken out some of the rows and the columns because they're extraneous to what we're looking at here. They will be more important when we get into Business 307, but these are the ones which are important here. So I'm going to take a look here at the questions at the very bottom for A, B, C, and D and how they relate to the output above here. So consider the output for the hours grades example above. What is the correlation R value? Well, the correlation R value is found right here, and it's the square root of the R squared value. Now, the thing to note here is it's always shown as a positive number here. And so in our particular case, of course, we did have a positive value of 0.57. It was positive when we did this by hand here. But if there was a negative correlation, it would still show it up here as a positive number here. How could you figure out whether this thing is positive or negative, though? your R if you were to do it by hand? Well, we'll see down here is that this is the slope. And we'll get to that in a moment here, but the slope is positive. And a positive slope means a positive correlation. A negative slope, a negative correlation. So you look at the sign of the x variable, and that will tell you actually whether the r squared value is equal to whether it's positive or negative. So in our particular case then, we would say that r is equal to the square root of the r squared value, which is equal to the square root of 0.325, which is equal to 0.570, and that's the multiple r value. Okay, and up here it says it has the same sign as the B1 value at the bottom of the page. All right, let's change colors here. The r squared value, we've already really talked about that, but it's right here. It's kind of a dead giveaway what this is, isn't it? So the r squared value then is 0.325, and that's generally expressed as a percentage, like that. Write the equation for the regression lines, and that's actually these guys right here. So these coefficients then are, here's your B naught, and this is your B1. So of course your B naught is your intercept, and then the B1 is the slope of hours, your x variable. When we get into multiple regression, we'll find that we'll have one intercept line, but then we'll have a line for each x variable. So we would have a line for hours, and then another line for age, and another one for, hours of working outside the home, and so on like that, or working outside of the class, and hours of sleep, and so on like that. So there'd be a line for each one here. But the regression equation then is found in that column of coefficients. So you'll remember that we had the regression equation that says y hat is equal to, and then you can just read those out, 37.700 plus 1.262 times x. And that is then talked about up here. Now, the last thing I want to note here is this guy right here. The p-value for hours shows whether the regression line is significant. So here's what we're testing here. I'm kind of giving you an idea of where we're going in terms of regression. The null hypothesis is that the x has no effect on y. They're not related. Now, we actually will write that differently when we get into Business 307. We'll write it in terms of the population slope. It'll be beta 1. Beta 1 is equal to 0 is how we'll write that thing. But what I want you to note here is the null hypothesis that we are trying to disprove here is that there's no relationship. And so remember your decision rule with p-values? What's the stats mantra? Well, the stats mantra is that if the p-value is less than alpha, then you reject HO. It's always the same, every stats problem on the face of the earth. And our default for alpha is 5% unless it's given to you in a problem here. And so what you do then is you take a look at the p-value for the x. Now there's a p-value for the intercept, but we are looking for the x. And in this particular case we have 0.0, let's write it down here. 0.025 is less than 0.05. Therefore, we're going to reject HO. I'm not interested again whether you know the hypotheses here, but basically it means a low p-value means that x is significant at explaining y. And so that's what we have in this case. We have a p-value of 3%, and that is less than an alpha of 5%. And so we would say, yeah, this is an important variable at explaining why. So ours is important at explaining the grade that a student gets. So that actually brings us to the end of Unit R. There's a bunch of additional problems here on page R6 and for the next few pages with their answers. And so I'd like you to work through those. And that brings us to the end of the course and the end of this unit. Thanks for listening.